Hello friends, today's question. In the figure, block A, B and C have mass 3 kg, 4 kg and 8 kg respectively. The coefficient of sliding friction between any two surfaces is 0.25. A is held at rest by a massless rigid rod fixed to the wall, while B and C are connected by a light flexible cord passing around a fixed frictionless pulley. Find the force F necessary to drag C along the horizontal surface to the left at a constant speed. Assume that the arrangement shown in the figure, that B on C and A on B, is maintained throughout. So it means this is the figure. B or C are connected using the string and A is connected using a rod. So let us suppose that T is the tension of the string and the force F is being applied on the block C. So in this case, let us say first of all we are going to draw the free body diagram for A, B and C, and which will be helping us in defining the various forces which will be associated with all these three blocks. So first of all, let us draw it for block B. So block B, there will be tension T, okay, and let us draw for block C also. And block C will also having a tension T, and the external force F is being applied on the block C, and block C will try to force the B to move towards right. Okay. So let us suppose, with the help of frictional force, let us suppose that is given as FR1 or rather FR2, and consequently there will be equal and opposite here also, FR2, and between block C and the surface, let us suppose there is a force of friction, that is FR1, okay. And because of the block A, there will be also a force, let us call that as FR3. So these are the various forces that will be acting on B and C. So we can say, and for block C, we are going to have F is equal to T plus FR1 plus FR2, okay. And we can find out what will be our FR1 and FR2. So this is our block C, and block C will be having the downward will be our MA plus MB plus MC to G, okay. This is our C, and there will be a normal, let us suppose that is NC, and value of NC will be equal to MA plus MB plus MC into G, okay. So we can say our FR1 will be equal to mu into NC, and if we substitute the value, we get mu into MA plus MB plus MC into G. This is our FR1. Similarly, we can find out the FR2. This is our block B. So in the downward direction we are going to have MB plus MC into G, and then let the normal be NB, which will be equal to MB plus MC into G. From here we can say our FR2 is equal to mu into NB, substitute value of NB, that is mu into MB plus MC into G. And yeah, I think A we can find out later on also, because so if we substitute the value we get F is equal to T plus FR1. FR1 is our mu into MA plus MB plus MC into G, and plus FR2 is mu into MB plus MC into G. Next is for block B. Block B, we have T is equal to FR3 plus FR2. So now we can find out our FR3. FR3 is because of block A. Okay. So we can say this is our block A. In the downward direction it will be MA into G, and let us put the normal NA. So we can say our FR3 will be equal to mu into NA, and that will be equal to mu into MA into G. This will be our FR3. FR2 we already know, so we put the value, we get this as T is equal to mu MA to G plus FR2 is mu MB plus MC into G. Let this be question number 1 and this be question number 2. And one thing more, MA is the mass of block A. Let me write it here. This is MA, this is MB, and this is MC. So if you substitute value of T from equation 2 in equation 1, okay, so we write using equation 2 in equation 1, we get F is equal to mu MA G plus mu MB plus MC into G plus mu MA plus MB plus MC to G, and plus mu into MB plus MC into G. You can take mu mg common from the entire equation, we get mu g. We have MA 1, 2, let me check it. There was small little bit mistake on my part. This will be equal to MA, not MC. Okay. So here written was MC, it is MA. Therefore it's MA and MA. It's not the correct one. So we come 1, 2, 3, and 4. So we get 4 times MA plus we have 3 times MB plus we have MC as ones. Now we put the value, we get F is equal to mu is given as 0.25, G is taken as 10, so we have 4 into MA, MA is our 3 plus 3 into 4 plus MC is 8. Okay. So if we solve it, we get F is equal to 80 Newton. So this is the force applied on block C. This completes the question. Thank you.